The Roads to Carbon Neutral, presented by TotalEnergies.
Hello, I'm Emma Crosby and welcome to The Roads to Carbon Neutral. This series examines how countries, companies and communities have set a clear goal to tackle climate change and achieve net zero carbon emissions by the second half of this century. In this edition, we're going to look at the burgeoning sector of energy storage and its growing role in helping to decarbonise the planet. Coming up, we look at why storage is crucial in the transition away from fossil fuels.
There's no question now to wonder if there is a need for storage of electricity. It's at which pace we will need it and which technologies will emerge.
Reporter Emmeline Nsingi-Nkosi gives us a global review of the storage projects in progress.
Plus, I'll examine the growth of the battery recycling industry.
And we discover the innovations that will power the future.
It's enough hydrogen to provide storage for the entire western United States.
To begin, let's delve into what energy storage is and what this technology means for the future of energy use. And to assist us, we've gathered a panel of leading global experts to further understand how energy storage systems will help us reach carbon neutrality. Since the Industrial Revolution, energies that powered innovation have happened in single transformational bursts, from wood and coal to gas and oil. In this modern energy transition, what's different is that renewable sources such as solar, wind and fuels like biogas and green hydrogen are converging all at once. The hybrid systems to integrate them will be key, and energy storage to fully ensure supply will be critical. Simply put, storage allows energy produced by hydrocarbons or renewables to be saved for times when needed. As the renewable energy era takes shape, storage allows for further uptake. The power generated by solar and wind, for example, is highly variable, so it's important to capture and store energy when the sun sets and the wind stops blowing. There are a myriad of ways to do this.
The high volume of renewable energy coming into the grid makes it more and more difficult for the network operators in order to balance the grid real time. Because the grid was made and was structured to be adapted to fossil fuels, which is not the case anymore. So it's no question now to wonder if there is a need for storage of electricity. It's at which pace we will need it and which technologies will emerge.
The resiliency of the grid is becoming kind of questionable in some places. In those instances where companies and organizations are having to go without power from the grid for a number of days, energy storage is a really good way of enabling them to actually have backup power and continue to operate in those times. So it provides that resiliency as well as decarbonisation.
Batteries are one of the most common forms of energy storage. Ubiquitous in our everyday lives, these have evolved in size and shape and chemical makeup, powering modern technology. So influential has lithium-ion become in our lives, the inventor was awarded a Nobel Prize.
In addition to powering smartphones, laptop computers, power tools and other modern tech, lithium-ion is the driving force behind electric vehicles, which require approximately 10,000 times more energy storage than a single smartphone. The EV revolution is driving the demand for lithium and other battery materials.
We see very good perspectives for the electric vehicles to participate into the stability of the network and to contribute also to absorb excess of power or to give back power when it is necessary. It's happening in Japan, because in Japan they are fairly in advance because they have bi-directional charge point operators, they have cars that are able to inject and also consume electricity. So the trend is increasing everywhere in the world.
There are still significant barriers to be addressed. Most importantly, battery costs need to be reduced and their efficiency and lifespan improved.
One other factor that we need to be very careful with is the supply chain and recycling of materials. When we see the demand for lithium, for nickel, for cobalt, with all the cars moving to batteries, we'll need to increase the supply of those metals, and we'll need to do it in an environmentally friendly way, which will require recycling.
While batteries continue to lead the market, other energy storage technologies are being developed and utilized.
For the grid-scale energy storage, it's not certain yet which technology will be the winner. Lithium-ion batteries, certainly they are a strong contenders. But I also see something else coming. For example, a nickel-hydrogen gas batteries. This has extremely long lifetime, very low cost. We'll be seeing a new technology like this coming up in the next couple of years.
There's also thermal energy storage, where heat is actually stored in molten salts or similar, and that can be used to create electricity. As well as those, there's compressed air and liquid air, where the air itself is actually compressed through compressors and then released, and that process stores energy as well.
With lifespans reaching up to 30 years depending on the electrolyte chemistry, redox flow batteries may provide unrivaled cost certainty versus other emerging storage technologies on the market. A flow battery is a rechargeable battery in which electrolyte flows through one or more electrochemical cells from one or more tanks. Flow batteries are currently double the cost of similar-sized lithium-ion configurations. Pumped storage hydropower utilizes water which is cycled between lower and upper reservoirs by pumps which use surplus energy from the system at times of low demand. During periods of high electrical demand, the stored water is released through turbines to produce electric power. However, this is not a global storage solution and it depends on a country's geography. Not every nation has access to powerful waterways as a natural resource. With flywheels, a giant rotor is levitated and spun by magnetic forces in a chamber. Energy can then be drawn from the system on command by tapping into the spinning rotor as a generator.
There is a big question mark around alternative technologies which can fill the gap of the renewables for timescales of days, but they need to come down in cost dramatically to be able to fill that gap.
All these storage systems can provide a wide range of valuable grid services, but not all of these technologies naturally fit within traditional regulatory structures. The energy transition demands a smarter grid to better maximize the mix of renewables and hydrocarbons.
2021 is a really exciting year for energy storage because installations are actually going to double this year compared to 2020. And so for the first time, the annual installations will be over 10 gigawatts. Then by 2030, we'll have tripled in size again.
The transition to a decarbonised future is unlikely to be enabled by a single energy storage technology. Today, lithium-ion batteries dominate the market, but it cannot remain this way. Energy storage requirements are already moving beyond the 5 to 6 hour threshold. The need for low material costs and minimal environmental impact will be required.
We probably need to have 100 times growth in the large-scale energy storage market, where you find the materials available, mining. You need to consider circular economy. You need to consider scalable production. I think the whole manufacturing economic transformation in the next few decades will be very important to enable that.
Continued visionary thinking will be necessary to ensure a framework for energy storage is in place to maximize efficiency gains and ancillary services to power a carbon-neutral future.
I think energy storage solutions are extremely important to reach net zero by 2050. If we have cheap energy storage for long durations, then we will be able to bring wind and solar maybe to 80%, 90% of the energy needs.
Emmeline Nsingi-Nkosi looks at the growing importance of storage for energy security.
Globally, it's estimated the number of people without access to electricity was at 759 million in 2019. And for those emerging nations where it is available, electricity can be expensive or unreliable, affecting an estimated 3.5 billion people. Inadequacies in grid infrastructure, even though a frustration can bring opportunity. Long-duration energy storage technologies can support a greater share of variable renewable energy into weaker power grids, helping to supply electricity without disruption, replaces the need for diesel generators, and provides seasonal balancing. Africa has huge potential for solar energy generation. IEA forecast Africa reaching 320 gigawatts in 2040, overtaking hydropower and natural gas to become the largest electricity source in terms of installed capacity. Solar's rise must coexist with a framework for battery storage. In the summer of 2021, Brazil's government agencies issued drought warnings as the country faced its worst dry spell in 91 years. This hit hydroelectric power generation, responsible for 60% of national supply, increasing fears of energy rationing. Brazil has 18 gigawatts of installed wind capacity, with wind power output highest in September. For this nation, power balancing and supplementing the grid is crucial. In Thailand, at the Lam Takong Dam, there is a wind-hydrogen hybrid project which combines 22 megawatts of wind and 1 megawatts electrolyzer to provide up to 10 hours of storage. India, with its ambitious target of installing 175 gigawatts of renewable energy by 2022, has plans to add 10 gigawatts of pumped hydro storage in the coming years. Wherever there is limited or unreliable power grid technology, the growth of distributed energy storage systems will be needed to keep pace with global demand. Back to you, Emma.
As we've already heard, the energy storage sector is in an era of innovation and progression. To tell me how TotalEnergies is becoming an industry leader, I'm joined by the company's Vice President of Energy Storage Solutions, Jean-Henri Cuillarière. Hi Jean-Henri, why is TotalEnergies investing in energy storage solutions?
We aim to become a leader in the renewable power by developing 35 gigawatt by 2025 and 100 gigawatt by 2030. The storage solution will be clearly part of that development. We are going to build plants in France, in Spain, UK, the US, and even in South Africa, where we recently have been awarded a new project. We are targeting to develop up to 3 gigawatts of storage solution by 2030. And by developing such solution, I believe that we will become a dispatchable renewable provider.
Tell us about the TotalEnergies storage operation in Dunkirk.
Dunkirk 1 was definitely a first of a kind. We have started early this year in January, and definitively the design we developed for that project will be replicated on the other side in France. In France, we have a battery directly connected using the existing connection of an industrial site. We are offering flexibility directly to the grid. When we will be developing energy management services, the design may be different, however, the principle will remain the same.
In 2020, TotalEnergies launched its battery-based energy storage project in Mardyk at the Flanders Centre in Dunkirk. Dunkirk's lithium-ion energy storage system will be used to provide fast reserve services to support the stability of the French power grid. TotalEnergies subsidiary SAFT has been integral to the project's success. For over 100 years, SAFT has been specialising in advanced technology battery solutions for industry, serving a huge range of market sectors, including transport, telecoms and healthcare. Their batteries have even powered space exploration. Michael Lippert, Director of Innovations and Solutions for Energy at SAFT, outlines why the success of this operation is informing the approach to other projects worldwide.
The ESS in Dunkirk is a lithium-ion battery energy storage system which has the capability of storing 25 megawatt-hours of electric energy. It can either inject 25 megawatts to the grid, then it is discharging, or it can absorb 25 megawatts from the grid and then it is charging. The purpose of this is to support the supply and demand balance of the electricity system and to provide peak power in case there are peak demands, for example in France at cold winter evenings. It is the largest battery energy storage system ever commissioned in France, but moreover it's just a blueprint. It's the first of a series of battery ESS that are currently built by TotalEnergies in different places in France. And the project also shows the strength of the cooperation within the TotalEnergies group. On one hand, TotalEnergies was developing the project. SAFT and its partners were providing the technology, and Total Flex is making sure it generates revenue by trading the different services of the battery ESS on energy and grid services markets. We are very proud of a 14 megawatt energy storage system that is operating since 1 year in a gold mine in Western Australia. It's an off-grid system, and the battery helps the operator to use about 50 to 60% of its energy from renewable wind and solar sources. There is virtually no limit to the scale of the overall energy storage system. As it is very modular, we can build it up to hundreds or several hundreds of megawatt and megawatt hours.
SAFT's manufacturing presence is global. With the addition of its Zhuhai site in 2006, it doubled its production capacity in China. Batteries such as those produced at the Zhuhai site are used at the Dunkirk project. We visited their site to find out more.
16 years ago, SAFT set up our first Chinese plant in Zhuhai for metering and rail applications. In response to the fast-growing demands for energy storage solutions in the world, we decided to open a new factory here in 2020. In Zhuhai, we manufacture our ESS energy storage solution product named Intensium High Energy Max 20. It is a one-step turnkey battery system to store energy and control the flow of electricity in grid systems. As the name suggests, it is a high-energy lithium-ion container which stores up to 2.5 megawatt-hour. We have installed an annual capacity of 500 megawatt-hour since we started our production. We aim at reaching 1 gigawatt-hour of annual capacity by the end of this year, 2021. As the world is now moving into a low-carbon future, our ESS products become more important as they serve as the backbone to the renewable energy integration. This is exactly the right illustration of low-carbon technology.
We'll learn more about TotalEnergies and SAFT collaboration later. Next, Emmeline takes a look at how storage, in addition to a microgrid, can help to ensure energy supply in non-connected areas.
Currently, utility-scale stationary batteries dominate global energy storage. But by 2030, small-scale battery storage is expected to significantly increase, complementing utility-scale applications. Interest in small-scale storage for residential use is the next frontier. TotalEnergies affiliate SunPower is combining its technology with storage to recalibrate how we access energy in our homes.
SunPower's SunVault storage system is a product that we offer for homeowners for the residential market. And essentially what it is it's made up of a battery with some intelligence that allows a homeowner with a solar system to capture that energy that the solar panels are generating for use at some later time. The other benefit that SunVault gives you is the ability to continue to power your house even when your grid goes down. And there's enough energy in a SunVault system to actually make it through the entire night so that when you wake up the next day and the sun is shining, if your grid hasn't been restored yet, you now have solar power to continue to operate the things that are important to you. Marrying a solar energy system with a storage system is the perfect way to continue to move towards a world where we can achieve net zero.
By providing the chance to make your own clean energy and store the excess for peak times and power outages, customers can get energy security and peace of mind.
When it comes to energy storage, SAFT will be instrumental in shaping the future. The task of developing technologies and determining the direction of research falls to SAFT's Chief Technology Officer, Kamen Netchev. We spoke to him about those aspects of his job that look into the future.
SAFT is a 100-year-old battery company. We have been providing batteries for demanding applications with very heavy requirements for life, for performance. We employ over 4,500 people across the world. 450 of these people are scientists and engineers involved in R&D and new product development. We are one of the pioneers in energy storage for renewables. We were one of the first to put containers with lithium-ion batteries supporting photovoltaic farms and wind farms. We are also involved in developing batteries for electric vehicles. We also participate in some very interesting but also challenging markets like space and automotive racing. In space, we have batteries that have been out there for 15, 20 years. This is an application where failure is not an option because there is no repair possible. Energy storage is constantly evolving. Applications are demanding greater and greater energy density, longer life, and of course, along with this, lower cost. Lithium-ion today is the dominant energy storage technology. The most common technology today is based on nickel oxide cathodes. This lithium-ion variety provides the best energy density and very good life. It is really what's been used in electric vehicles and energy storage for the renewables in the last 15 years. SAFT is looking at developing the next generation of technology called solid state. Solid state is a technology increasing the overall energy density of the system, increasing the safety, and ultimately lowering cost. We have the full support of TotalEnergies, and we have structured a very strong and competent program for developing solid-state technology at SAFT. We expect that solid-state will power electric vehicles and will be also the technology of choice for the grid.
And to end the show, we examine some of the most exciting experimental work being carried out in the storage sector. Emmeline has more.
After 2030, two issues will collide. There will be a surge in current EV batteries reaching the end of their first life and a lack of materials to replace them. Recycling will help to relieve the pressure on primary supply. As the technologies and methods of recycling improve, the market for battery recycling will grow also. In 2020, its value was estimated to be more than $1 billion. It is anticipated to grow to approximately $38 billion by 2030. Canadian company Li-Cycle believes it has developed a method to make recycling commercial.
So Li-Cycle is a commercial lithium-ion battery recycler. We take all types of lithium-ion batteries, so taking the smallest battery you can from your mobile phone to the biggest battery you can, be it in a passenger vehicle, and everything in between. And importantly, in a both economically sustainable fashion and environmentally sustainable fashion. It's a two-stage process. We take in lithium-ion batteries of all types, whether it be production rejects and scrap all the way to full electric vehicle batteries. We break it down to intermediate materials. And the second step of what we do is the hub, where we take that intermediate product and we make those finished materials to go back into new lithium-ion batteries again. Li-Cycle takes all types of lithium-ion batteries and recovers 95% of those materials to go back into new products and new lithium-ion batteries again. That's a massive shift away from historically having 50% and below mass recoveries, and hence this is revolutionary for the lithium-ion battery supply chain.
In 1958, NASA first started using hydrogen as a power source. Here on Earth today, hydrogen used to decarbonize the power sector shows promise. Power balancing and energy storage are considered essential components to integrate renewables at scale and successfully operate a low-carbon power grid. Mitsubishi Power has developed methods to do this, utilizing green hydrogen. Their president and CEO, Paul Browning, explains further.
Batteries are great for storing power for a couple of hours, but they're very, very expensive if you want to store power for days or weeks or months or seasons. And that's really where green hydrogen comes in. Green hydrogen is the most affordable way today to store renewable power for long periods of time. But as we drive the cost of green hydrogen down, it's going to start to become a low carbon fuel that'll be used, for example, in the transportation sector for long haul trucks, or maybe for shipping purposes, or even air transportation. But Mitsubishi Power, we're involved in a project called the Advanced Clean Energy Storage Project. We're also involved in the Intermountain Power Project, and those two projects are connected to one another. So the Intermountain Power Project is going to be a power plant that's going to be able to use hydrogen as a fuel. There happens to be a very large salt dome that sits right underneath the Intermountain Power Project. And it's exactly the kind of salt dome that is used in the Gulf Coast of the United States to store hydrogen for the refining industry. We're going to produce the green hydrogen using a large electrolysis facility that we're going to build above ground. So a really large battery energy storage project is 1,000 megawatt hours. One cavern in a salt dome is 150,000 megawatt hours. And in the first phase of our Advanced Clean Energy Storage Project, this salt dome has the capacity to put 100 caverns in it. So we have the ability to store just a truly massive amount of hydrogen. In fact, it's enough hydrogen to provide storage for the entire Western United States.
The green hydrogen storage methods developed by Mitsubishi Power are the first of a kind in the United States.
There is so much yet to come for energy storage. Which long-duration energy solutions flourish will be determined in the coming decades.
Well, that is all for this edition of The Road to Carbon Neutral and our examination of energy storage systems and their role in powering a more sustainable future. If you'd like to find out more, please visit roadstocarbonneutral.com. Thank you for watching, and goodbye. The Road to Carbon Neutral, presented by TotalEnergies.